Good evening, everyone.
Good evening, welcome.
So I think we'll start right away so that we don't we can just use good we can have good use of our time.
How was your trip, ma?
Fine, thank God. I arrived safely. All right, so let me just share my screen and then we'll continue with the business of today. Any questions? Any questions from correlation? No questions.
We were done. We started regression. So
Okay, so
started...
I can't find my pen. You help me and take note of those who will be assigning marks to this evening, please.
Okay, ma.
I just arrived, so I don't know. I don't know how to waste time. Okay, so let's start regression again. We said that at the end of. Can you guys see my screen well? But you will have the PowerPoint, so it shouldn't be an issue. Okay.
Yes, ma'am.
Sorry, hold on. All right. Okay. At the end of discuss, students were able to define regression, its purpose, and identify dependent and independent variables. That's one key thing that makes regression different from correlation. Remember that I said one of the characteristics of correlation coefficients is that there's symmetry. When you find the correlation between X and Y, it will still give you the same thing when you find the correlation between Y and X, isn't it? But for regression, it's not like that. Your ability to identify your dependent and independent variable makes you know that you're on the right course. So in regression, there must be a dependent variable, which is your Y, and your independent variables or variable, which are your X or X's. So we must be able to make that distinction between correlation and regression. In correlation, anything can be X or Y, but in regression, you cannot carry Y and make it X. You cannot carry X and make it Y. It means you have changed your objective totally. You have changed the reason why you're carrying out the regression. We say we use ordinary least squares to estimate regression equation coefficients, and as we go on, you'll see those coefficients and how we use them to do prediction. And then you'll be able to interpret regression outputs like coefficients, R squared, and F statistics. We should be able to test regression coefficients using T statistics and p-values. So I'm sure that you have gone through the slides. I've given the different levels for p-values and their level of significance. T might be a little bit confusing. It's easier to use P than T. Then you should be able to use regression to predict future value of the dependent variable. Can I move on? Can I move on?
Yes,
Eh?
ma'am.
Yes, ma.
Yes, you can
Yes,
move
ma'am.
on.
All right. So earlier I said regression is a statistical tool that we use to examine the relationship between a dependent and independent variable or variables. Basically, regression is used to predict. You know how we have prophets who see into the future. Some people call them seers. That is what regression does. We use regression to predict. Not necessarily, regression does not necessarily cause causation. We said that correlation is not causation. It just shows there's a relationship. So regression also shows there's a relationship and it helps us to predict. It doesn't necessarily imply causation too. Is that clear? I would say for regression, we have the dependent variable. That is your Y. Dependent variable is your Y. It is also called the outcome variable. It is called the regression. It is called the explained variable, and it is called the response variable. It is response variable because it responds to the independent variable or variables, as the case may be. So all these names we have for dependent variables, just like my name. My name is Hefziba. My name is Onyeje, right? So it's still your name. Anybody can call me anyone at any point in time. So dependent variable, if I say outcome, it shouldn't be strange. If I say response variable, it shouldn't be strange. We are all referring to the same thing. And it's good we know these names. For independent variable, the other names are predictors. Independent variable are your x's. Dependent variables are your Y. Are we following? You cannot interchange like correlation. In correlation, it doesn't matter. You can say this is Y, this is X, this is X, this is Y. But it is not so for regression. So please, let's take note of that distinction. Your independent variables are your predictors, your regressors, exponential variables, covariates. They are also known as covariates. So when we say covariates, let me not go deep. Let's just continue. Okay. Sometimes they're often known as controls. So why regression? We say regression helps us to quantify the relationship between variables. This is the main use of regression for prediction of social outcomes based on known data. And then it helps in testing social theories and models. Of course, when you're able to predict, you find the relationship, you will now test to see whether a theory holds or a model holds true or not. But the main purpose, so you can see when we say why regression, we did not say regression causes. It helps us to know what causes something. It helps us to predict. Regression does not necessarily mean causation. Are we following? Have I lost?
What is it?
Yes. Is there any challenge?
The network is frustrating.
My goodness. So you people have not been hearing me?
No, some of us are hearing you.
I've been hearing you, ma.
So that
Some
means
of
the
us are
fault
hearing
might
you.
be from your end. All right, so I've said that the main purpose of regression is to predict social outcomes based on. So we gave these examples. I even used these examples to assign marks. I said application in social standards. For example, if we want to measure how socioeconomic status, I want to ask, when we say socioeconomic status, who can tell me what we're referring to? What could we be referring to?
Independent variable, ma.
We were
I know
we are
socioeconomic
talking
status
about
is
poverty.
okay. So when we say
Poverty and
socioeconomic
wealth.
status, well, so it could be wealth, it could be education,
Income.
welfare.
Education. Mhm.
Yeah, so all of those could form your socioeconomic status. Now, applications of regression in social standards. We can use it to measure how socioeconomic status. Socioeconomic status is your independence. When we say something is independent, what do we mean? You can do without something, isn't it?
Yes.
But when something is dependent, it means you respond to something. The independent variable does not respond to anything. It is the one that something responds to. So in this case, socioeconomic status is the independent variable. It is educational status that responds to socioeconomic status. And since, educational attainment. And since educational attainment in this case is our dependent variable, socioeconomic status we're referring to here cannot be education again. So maybe it is income. Are we following? It could be any of those criteria people use to judge socioeconomic status aside for education. What am I saying? What you have as dependent variable cannot be your independent variable. This is the point I'm trying to make. Are we following?
Yes, ma'am.
Is the class following?
Yes,
Yes,
let
ma'am.
me ask
Yes, ma'am. We are
Hello,
following,
ma.
ma'am.
Yes.
Can I ask a very typical example?
Who is talking like this? Somewhere, Hifa, please, can you mute your your mic?
Takwe, please.
Ma, I want to ask,
Okay,
if
well,
a match
yes.
is in the box and you never strike it, can we say a stick of a matches without being struck is like the pocket of the matches is an independent value? Can you match that to our understanding or to my understanding? A stick of matches and the pocket, which one is dependable and which one is independable?
So when we say dependent and independent variable, you as the researcher determines what is your independent variable and what is your dependent variable. So for example, I might do a research so that you're clear. It's not like it's cast on stone. I may do a research and say I want to look at the effect of income on education. Are you following? Now, income is my independent variable. Education is my dependent variable. You can decide to do a research of education or income. In your own case, education becomes the independent variable, while income becomes the dependent variable. So there's nothing like I will see age and tell you whether it is dependent or independent. It depends on what you want to do, the goal you want to achieve. Are we following? So it is how you frame it. It's not like quantitative and qualitative variable that when you say, oh, this is quantitative and this is qualitative. You can't just say a variable and say this is dependent or independent. The researcher decides what is his or her independent variable and what is his or her dependent variable. Yes, Usman. So
Good
in that
evening.
case, sorry, Usman, Jigba, for you now, you said matches and it depends on what you want to do. Are you following? You can't just look
Yes.
at something and say it's dependent. So it depends on what you want to do that decides on what to be your dependent or independent. Yes, Usman. I don't know if you are clear, Jigba.
Yes, ma'am.
Okay, Usman.
Ma, good evening.
Good evening, please.
Ma, please, I don't understand when you where you said dependent is X and independent is Y. Please, I don't know which one is which. Is it the dependent that is X or the independent that is X?
Dependence is Y. Why? So as
Okay.
we're teaching, you can also be jotting because some of
Yes,
the things
that's
I
what
say
I'm doing now.
you won't find
Independent is
in the slide. Are we
Yes, ma.
following?
Yes, ma.
So some of the things I'm saying you will find in the slide. So it's also wise if you can jot so that on your own, that in your own spare time, you can now match. If there's something you
Yes,
don't
ma.
understand, you can go back to. So your
Yes, ma.
dependent is your Y. Independent
Okay,
is
ma.
your X.
Okay, ma. Thank you very much.
All right. Any other question? All right. So in our second example, analyzing the effects. Who is doing this in the class now? In our second example, analyzing the effects of government policies. So sometimes the word you see before
Hello,
two
ma.
variables. Yes.
Hello, ma. Good,
Yes.
good evening, ma.
Good evening.
Please, I'm a little bit confused. Because
Okay.
it depends on what the researchers mean that will show him or her the dependent and independent variables. And my question goes like this. In the situation where the data is being released, then how are we going to know the dependent and independent variables?
In a situation where the data is being released.
Yes, ma.
So, for example, in my PhD, I used an already existing data. I used panel data. But what I wanted to do helped me to structure the data in a way that I wanted it to. Are we following? So I looked at the effect of different things on stunting and wasting. Because I'm looking at the effect of different things on stunting and wasting, from my data, I took stunting to be my dependent variable. In another objective, I took wasting to be my dependent variable. So it is not the data that determines what you want to. The objective you have set out to achieve is what will help you determine what to be your dependent. So these are some of the things that your supervisor will guide you on. Because honestly, I don't think I'll be able to drive home everything in one class. Yes, Bem? Bem, you want to say something? We need to be mindful of time. All right, so in our second example, we're looking at analyzing the effect of government policies on social equity. So this word "on" helps you to know that social equity is your dependent variable.
Hello?
Government policy.
Hello?
I don't like it when you interject. I gave you opportunity to talk. You didn't talk, and I've moved on. What's the challenge, Bem?
I came online at about 13 past 7. I just want to request if you can go back to regression.
No, it's not possible. I can't keep doing this always. No, it's not possible. I can't keep doing this always. That's why you have the materials. You can go through it. There's a point where we need to be firm. It's not always that one has to be this flexible. So in our second example, we're looking at analyzing the effects of government. Please, if I'm talking, kindly mute except you want to talk. In our second example, we're looking at the effects of government policies on social equity. So you see this word "on" helps us to know that social equity is a dependent variable and government. Please mute. Oh my goodness. Medugu silence.
Sorry, ma.
In our third example, we're predicting the likelihood of social mobility based on income and education. So when you say something is based on, it says that it lets you know that it is dependent on. So what is dependent on social mobility is dependent on income and education. So in this example, social mobility is our dependent. I'm going to continue regardless of the sound I'm getting from the background, and I'm not going to go back because I don't have all the time to keep going back and forth. So in this example, social mobility is the dependent variable, while income and education are the independent variables. So we said there are two types of regression, the simple linear regression and the multiple linear regression. In the simple linear regression, we're exploring the relationship between just two variables. It means we have, of course, dependent variable has to be one. It is independent variables that can be more than one. You have only one y, then you can have different x's, right? So, but for simple linear regression, you have one y, one x. Simple linear regression, you have just two variables, your dependent variable and your independent variable, your y and your x. Example, I'm not even going to plead with anybody to mute. If this is how I want the class to continue, no problem. An example is to assess the impact of socioeconomic background on academic performance. So we just have two variables, socioeconomic background, academic performance. I want to ask which is the dependent and which is the independent variable.
The socioeconomic is
Economic is
independent variable and
academic performance is dependent.
Beautiful. So the socioeconomic background, so it's even DSF, see it as X. I didn't even look at it very well. Y academic performance is Y. Remember that the Y is always your dependent variable. So it is automatic. Anywhere you see Y, just know that that is your dependent variable, right? So this is a perfect example of simple linear regression where we are just looking at two variables, one Y, one X. In the case of, this is what the regression equation looks like. Are we following? This equation has not even been written. Yes.
Excuse me. Sorry, I want to ask a question.
I'm all ears.
Yes.
I thought you said you wanted to ask a question.
Maybe the network is fluctuating.
you can continue.
Who is this
Maybe
person
it's
now? That person should mute. What is going
So,
on?
what I'm trying to say is that, in fact, this equation, although this equation is an example, but it's not correctly written. Why do I say so? When you write a regression equation, so I'm going to emphasize this during a regression, there must be a subscript. That subscript tells us whether you're using cross-sectional data, whether you're using time series data, or whether you're using a panel data. But because this is an example of just to explain what a regression line looks like, this is fine. But in your own work, never write your models without subscripts. So what do I mean by subscript? For example, this Y, we have small I here to show that that I tells us that it is a cross-sectional data. And what does that mean? It means you have gone to the field and collected the data in that time. If it was T, if it's Y and small t here, it tells us that you're using an already existing data and it's time series data. If you have Y and then the subscript is small I and small t, it means you're using a panel data that has two dimensions, the cross-sectional dimension and the time series dimension. But for the purpose of this class, I think this is okay. Now, in your regression line, you have Y is equal to B0 plus B1 X plus E. Like I said, your Y is your dependent variable. It is your response variable. It is your outcome variable. Your B0 is your intercept. And I said intercept is the value of Y when X is 0. What do I mean? If, for example, X is 0 here, what happens? Y will still be equal to B0 plus your error, isn't it? Is the class following me?
Yes, ma.
Yes, ma.
From our normal math, if this X is equal to 0, we know that B1, anything multiplied by 0 is equal to 0, isn't it? That means Y will still be B0 plus error. Of course, we don't even calculate our errors. We don't interpret our errors. So I said B0 is the value of Y when X is 0. Like I give an example. This your B0 is an example of whether you work or you don't work. You know you must eat food. How the food comes, we don't know. That's what we call autonomous consumption, right? In economics. So that B0 is the value of Y when your x, regardless of what your x is equal to 0. It is constant. Remember what we said about constant? It doesn't change. So whether x is there or not, y must always be equal to something, and that is b naught. Now, b1 are the coefficients, and b1 is also known as the slope. It is that coefficient we are looking for to help us determine what the relationship looks like, and that coefficient will help us to do our prediction. We'll see that as we go on. E is your error term, and I said error term means, for example, if we're looking at the effect of socioeconomic status on education, we know that socioeconomic status might not be the only thing that affects education. There are other things that might affect your dependent variable that you might not capture in your model. It's also not even possible for you to capture everything. There are some things that will affect your dependent variable that you will not be able to measure, that you don't even have data on. So that E subsumes all those effects. Are we following?
Yes, ma'am.
So the error term captures the effect of other factors that might be explaining your dependent variable that you have not modeled in your equation. Is this clear?
Yes, ma'am.
Yes.
So for example, if we want to examine how income affects life satisfaction. Now, so this example is still, who can tell me, is this simple linear or multiple linear? Is this simple linear regression or multiple linear regression? Raise up your hand if you want to speak, please. In our example, okay, yes, Kumaden.
My simple linear equation.
Why did you say simple linear equation?
Because it has just two variables.
Beautiful. So we just have one y and one x, right? Fire, please kindly note Kumaden's name, 1 mark.
Okay, ma.
So in this example, we want to see how income affects life satisfaction. But we know that it is not only income that affects life
So
satisfaction.
should it be that anytime I add somebody 1 mark, I should add myself 1 mark?
How now, Fire? Are you saying I shouldn't trust you? Are you saying I shouldn't trust you?
At your comment.
Mr. Fire, please be coming down.
All right, so let's go on. Let me try to explain error term from this example that we have. Now, we want to see how income affects life satisfaction. So income is our independent variable, while life satisfaction is our dependent variable. But to be honest, is it only income that affects life satisfaction? Don't we have, like somebody said, we have rich people that are not happy with life, isn't it?
It is.
Yes.
So there might be other factors. So let's take, for example, that you have not modeled those factors in your equation. All those factors that affect, so X is going to tell us the effect of income on Y. The other things that affect life satisfaction that you have not put in will now be captured in your error term. Do we understand? Do we understand?
Also means
this is serious sacrifice. I'm just arriving my destination. I'm trying to do this, and then this evening we're just having different interruptions. People are just leaving their mic. They are not even concentrating. They are talking with their families. So let me let you know, there are some people who have carried over this course that in this class. It is not automatic that you pass once you don't meet the threshold of 50. You are coming back to, and this is a 3 credit unit course. I said this earlier on to show the importance we should attach to this, but I'm hearing people from the background talking to their families. It's fine. The day of reckoning is going to come. Yes, any question?
Yes,
Do we
ma,
understand
I have a
error
question.
term from what I said? Okay, let's
I
hear
have
you.
a question, ma.
Okay.
I have a question, ma.
Okay.
Ma, if you look at these variables, you have B1, BI, which is
That's
the
not BI,
coefficient
that's
of X.
B1. Okay, you're looking at, okay, the explanation. All right.
And there's BI, and then there's B subscript 1, which is the slope. And in the equation up, I can't see the B subscript I.
So it's supposed to be B1. Your coefficient and your slope are the same thing.
Okay. Thank you, ma'am.
Any other question? Thank you for noting that. All right, so let's go on. So the example I just gave was just to drive the explanation of error term for us to understand what the error term does. Error term captures the effect of variables that have not been modeled into your equation on your dependent variable. Okay. And simple linear regression, multiple linear regression is going to be easy peasy. What is the difference? In multiple linear regression, you don't have one x, you have x's. Your x's are more than one. And multiple linear regression actually tells you so simple linear regression is just like the senior brother of correlation, because you are just checking two. Correlation also checks two. Are we following? The only difference is that you'll be able to predict, right? So it will tell you whether it is positive or negative. For multiple linear regression, you have more than one x, and the truth of life is that one thing cannot just affect your dependent variable. There will be multiple of things that affect it, and your ability to capture them makes your model better. Now, multiple linear regression models the relationship between a dependent variable and multiple independent variables. Multiple could be 2, 3, 4, 5, as much as you want to throw into your model that makes sense. Now, this, like I said, so this is more realistic in social sciences, as outcomes are rarely influenced by a single factor. So we cannot say it is only income that affects education. There must, in our social lives, there are other things that affect education. Even whether you have peace in your family will affect your education. There are different things that affect education. So multiple linear regression makes sense when it comes to the kind of work we do, because it's very difficult for only one factor to affect an outcome or determine an outcome. Now, so this is what the multiple linear regression looks like. So we still have y, our dependent variable. We have our intercepts. So for the first x, this is the coefficient of the first x. For the second x, so this is x1, and you have b1, x2, and b2. So what we have here means as many x's as you have up to the point of xn and bn. So you must have a corresponding beta for every x you have. So this b is not normal b, it is called beta. Are we following?
Yes, ma'am.
So for every x, you must have a corresponding beta. Your corresponding beta is your coefficient. It is your slope. Your coefficient or slope is that okay?
Okay, yes, ma'am.
So that's the only thing. In multiple linear regression, you have more than one x, while in simple linear regression, you just have one x. But the explanation still stands. So now in multiple linear regression, one thing we need to know, for example, maybe in your work, let me go back to this example. Your objective is to determine the effect of here's an example. You want to determine the effect of income on life satisfaction. So let's go. So let's assume that you want to determine the effect of income on life satisfaction, and this is your income x1, and then this is your life satisfaction, and then you put other variables that you think can affect life satisfaction. This one now that is the main thing you're looking at is your treatment variable. Are you following?
Yes,
This
Yes.
x1 that is the main thing that you want to find its effect on this is your treatment variable. The rest are your covariates or your control. Are we following? So that when you hear these
Yes, ma'am.
terms, they are not strange to you. So the particular variable you're interested in is your treatment variable. Then you can have
Okay.
other covariates or other controls, other independent variable. You can just call them controls. Why the main thing you want to look at, but all of them are still independent variable. But your main variable of focus is your treatment variable. So
Okay.
every other explanation still stands. Other explanation for simple linear regression still stands for multiple linear regression. Any question? Any question? So in this case, our B naught is the value of y when all the x's are 0. In the first one, because it was just one x, when that x is 0. But in this case, when every other factor is 0, your y will still be your B naught. So every other explanation stands. The difference is just that you have more variables compared to your simple linear regression. So an example could be understanding how education, are we seeing income, age together affect social mobility. In the first one, it was just education and social mobility. But now we have thrown in other covariates or other controls. So if education is so the way you write your objective, it can be, objective can be to determine the effect of education on social mobility. But because it's not only education that affects social mobility, in modeling your equation, you can now put in income, put in age. I want to ask, between education, income, and age, which is your treatment variable? Please raise up your hand if you want to respond. Rosemary, yes. Rosemary. If Rosemary is not talking, Rosemary, you need to mute to talk. You need to unmute, sorry.
Okay, you said between income, education, and age, which is the
Which is your
treatment
treatment
variable?
variable? Hold on.
Income.
Hold on. Listen to the objective again.
Okay.
To determine the effect of education on social mobility. But in that regression, you have education, you have income, you have age. Which is your treatment variable?
Education.
Beautiful. Education is your treatment variable because that is our major concern. But we know that it's not only education, so we have to throw in other covariates that might affect social mobility. Do we understand?
Yes.
Yes, ma'am.
Yes, ma'am.
Okay.
So this the multiple linear regression model allows for controlling the effect of one predictor while assessing the effects of others. Hence the common term ceteris paribus. So in explaining results, right? So you can say the effect of education on social mobility is blah 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 blah, while holding other variables, and these other variables you are talking of are income and age constants. Don't worry, as we go further, we'll break it down. Any question?
Yes, ma. Hello, ma. The network is not allowed. The network is not allowing me to say something. Actually, the slides that is on the screen now was what I had wanted to contribute in as giving example to.
Tapu, we cannot hear you again.
Yes, Manasseh, do you want to say something? Because we don't have
Yes,
the whole
yes.
day. All right, let's hear you.
I want to ask a question. Ma, please, don't be offended. I will take us back a little. Let me talk about the simple linear regression that we spoke about. I understand that there was an equation in particular. These are the equation of the simple linear equation. You say it was B, which was B0. And then in the multiple linear equation, we also have beta, which is beta 0. But in writing these two, the B and the beta, there is no difference if maybe I may be making a mistake. But
Okay, so I get you now.
There's no
I might
difference.
be saying B. There's no B here. They're all betas. Beta naught, beta 1. So maybe I started by saying B0, B1. They are all beta. So you can see that the B is going down. It's not your normal English alphabet, right? So we're using a Greek alphabet here. It's beta. So this is Y is equal to beta naught or beta 0 plus beta 1. It's the same thing here. Whether it is simple or multiple, they all have beta 0, which is your intercept.
Thank you very much. I'm grateful. Thank you. Thank you. All right.
So there's no B.
Okay,
Please, let's clear that. It is, beta looks like B. So maybe that might have been slip of tongue from my own side. They are all beta.
All right. Thank you, ma. You can
Any
go on.
other question? So key concepts in regression. So you can see that we're repeating because we need you to understand these concepts over again. This is not the first time that we're emphasizing this concept. Dependent variable. Your dependent variable is your Y. Your dependent variable is your Y. Your dependent variable is your Y. And your dependent variable is the outcome being predicted or explained. For example, you want to see the effect of education on poverty level. Poverty level is your dependent variable. You want to explain poverty level to see how it responds to income. So your dependent variable is your Y, and it is the outcome being predicted. Now, independent variable, you can see there's S in brackets. So independent variable refers to simple linear regression. When we say independent variables, we're referring to multiple linear what? Regression. Now, the independent variable or variables, as the case may be, is the factors used to explain changes in the dependent variable. Remember that your dependent variable is your response variable. It responds to something. The things it responds to are the independent variables. Is this clear?
Yes.
Yes, ma'am.
Yes, ma'am.
Now, your slope, your B1. Your B1 measures the change in the dependent variable for each unit change in the independent variable. Now, this B1, you understand it better when I show you, we actually see a regression result, and then I'll teach you how. Of course, B naught, but in your thesis, nobody explains B naught. B naught is there. Our interests are your slopes, right? Your slopes are our major interest. Your ability to explain the effect of your slope on your dependent variable. Nobody explains B naught. Even error term does not even come up in the result. All right. Then we have beta naught. So this is the predicted value of the dependent variable when the independent variable is 0. This is your constant. We have error term. Error term represents the unexplained variation in the dependent variable. What do we mean? The other things that affect the dependent variable that you have not captured in your model. That's why we say the unexplained variation. The unexplained things that might be causing response in the dependent variable. It accounts for random factors that affect the outcome. Those random factors that you might not have measured, those random factors that you have not included in your model, your error term explains those factors. The error term represents all factors that influence the dependent variable that are not captured by the independent variables. These are all the things I've said before. It accounts for randomness, measurement errors, and omitted variables. So sometimes maybe you have not measured something well, the error term is going to subsume that effect. Randomness, the error term is going to subsume that effect. Maybe you have not really included a variable you're supposed to include, that's omitted variable. The error term is going to subsume that effect. It's just that in regression, in advanced classes, even if you have omitted a variable, you try to tell us what your omitted variable bias is. Well, I don't think that is relevant here. So there are some assumptions that guide regression analysis. Are we together?
Yes, ma'am.
Yes, ma'am.
Or it's becoming too complex?
But we may assimilate. It's just a matter of time.
Okay, thank God. So to ensure valid results.
Will help us.
Amen. He will. So to ensure valid results, regression analysis relies on certain assumptions. You can't just say you're doing, you just pick variables and say you're doing regression. If your regression does not meet up with these assumptions, then we cannot rely on your results. Remember I said researchers, the kind of crimes that we commit, it's just that, we're in Nigeria where everything goes. When we say politicians are deceiving people, that is what researchers do when you don't carry out your research correctly, right? So for you to do regression, certain assumptions should have been met before you can do regression analysis. The first one is linearity, right? When we talk about linearity from our correlation, that means it is straight. So the relationship between the independent and dependent variables should be linear. It should be straight. So if you carry out, so how do we, so when I carry out my normal analysis, when I do my research, how do I try to determine linearity? Because by me looking at variables, you cannot determine whether they are linear or they are not linear. What do? I graph them. I do a scatter plot. From a scatter plot, remember what we said earlier on in the correlation. From a scatter plot, once you see a pattern, you'll be able to decide whether it is linear or it is non-linear, or whether there's no relationship at all, right? So there are other things you can use if the relationship is non-linear. But if you want to use regression, the relationship, so you can now graph your, so for example, if you have 4 independent variables and you have 1 dependent variable. So in the example we gave, let me see the example we gave, sorry. Okay, so for example, in this example, we're looking at the effect of education, income, and age on social mobility, right? So for you to check the linearity, you will do scatter plot of education and social mobility and see if you get a linear pattern. You will do scatter plot of income and social mobility. So these ones are checks you will do before you carry out regression, just to be sure that you are not defying any of the assumptions of regression. So you do age and mobility. Once you're able to get a straight pattern, then you can say, yes, linearity exists between the variables you want to regress. Is this clear?
Yes, ma'am.
So you can't determine linearity by mainly looking at variables, right? You have to do a graph so that it shows you the pattern. If it is like this, you know that it is non-linear. You go and search what are the kind of models I can use for non-linear relationship. You will find other models, but definitely not regression. Is this okay?
Yes, ma'am.
Do we understand this first assumption, linearity?
Yes, ma'am.
Yeah.
Yes, ma'am.
You are, yes, you have just discussed the first one. You will take the second one now.
Obviously. Okay. So the second one is no autocorrelation or no serial correlation. So now, this autocorrelation majorly applies when you're using time series data. What does it mean? So autocorrelation means that your errors are related. Are we following?
Yes, ma'am.
Yes.
But the normal assumption for regression is that your errors should not be related. Are we following? So let me give an example. Let me go back to, okay, when we talk about errors, so that you understand what we're trying to say. Let me go back to this correlation example. Can we see this?
Yes, ma'am.
Yes, ma'am.
Can everybody see this?
Yes,
So,
ma'am.
if this, forget that this is correlation, I'm trying to explain regression now. If this was regression, we have our X, our Y. Which one is dependent variable? Which one is independent variable? From what I have on the screen, which is
Ma'am, please come
dependent?
again.
The S
The
is
From
X
what
dependent
we have on the
variable.
screen, which one is dependent and which one is independent?
The X is independent.
Just call.
The X, which is the hour study.
The score is dependent
Okay,
variable.
beautiful. All right, okay. So when we talk about error term, that means we're saying hours studied affects test score. For this first observation, oh, sorry. My goodness. Okay. For this first observation, these first students, are we following?
Yes, ma'am.
For these first students, okay. Beyond hours studied for these first students, there will be other factors that might affect test scores. But because they are not captured, there's error term for these first students, there will be error term for the second student, there will be error term for the third student, error term for the fourth student, error term for the fifth student. Are we following?
Yes, ma'am. Yes, ma'am.
Now, autocorrelation is saying autocorrelation autocorrelation is saying that the error term of student 1 should not have any relationship with the error term of student 2. The error term of student 2 should not have any relationship with the error term of student 3. Same thing for 4 and 5. Now, without these examples, if I had just said autocorrelation, you will not understand what I'm trying to say. For every observation, there's an error term. Are we following?
Yes, ma'am.
Yes, ma'am.
Is
We
there
are
anybody
following.
that doesn't understand this now?
We are following.
So those error terms, so for example, this is E1, E2, E3, E4, E5. E1, E2, E3, E4, E5, autocorrelation says they should not. So if you do the correlation between E1 and E2 should be 0. And E1 and any of the E's will be 0. E2 and any of the E's will be 0. That is autocorrelation. If it is related, it means you have defied the assumption of autocorrelation. Is that clear?
Yes.
Yes, ma'am.
And again, you cannot determine autocorrelation with your eyes. There are tests that you do that will help you. So for the first one, linearity, you cannot determine linearity with your eyes. You will use a graph to tell you whether it is linear or not. For autocorrelation, there's a test. I've forgotten the name. There's a test you will do, because if you look at your variables, you cannot determine by looking at your observation if autocorrelation is there or not. So you carry out a test. From the result of the test, you will know whether there's autocorrelation or not. If there's autocorrelation, you can correct it before you move on to do your regression. Is that clear?
Test.
Okay.
Maybe that can be test retest.
No, it's not test retest. Test retest, you do that to check for the reliability of your research instruments. It's not test retest.
It's okay, ma'am.
The second one, the third assumption is homoscedasticity. Are we following?
Homoscedasticity.
Homoscedasticity.
Yes, ma'am.
What does homoscedasticity say? It says the variance of the error term should be constant across all the values of the independent variable. So we are saying that variance, that's the gap from the error term. So the error term, if you find the mean, the gap of one error term to the mean and the gap of another error term to the mean should be constant across all the values of the independent variable. So just know that there must be homoscedasticity. And again, homoscedasticity is just like autocorrelation. You cannot determine it with your eyes. There's a test you perform to know whether your observation is homoscedastic or not. If it's not homoscedastic, you can always correct it before you move on to assumption to your regression. But if any of these assumptions have been defiled and you move on to do your regression, then you're saying your result is not valid. If it's a good journal or a good reviewer, they will ask you that where are we call them diagnostic tests. Where they want to see your diagnostic test before they can even take your results with a pinch of salt. So you can't just go straight to do your regression without your diagnostics that will tell us that yes, all the assumptions that are supposed to be kept have been kept before you move into your regression. The fourth assumption is normality of error terms. What do I mean? Oh, I'm sorry, I didn't travel with my board, so I won't be able to even draw it. So when we talk about normality, what do we mean? How many of us know this bell they ring in schools for assembly and other things?
Yeah, we know it. We all know it.
I remembered it.
Okay. So when we are talking about normality, normality takes the shape of a bell, right? So look at my cursor. Okay. Let me stop sharing and see if I can use, hold on. Let me stop sharing and see if I can use the whiteboard off. New whiteboard. Let's see. Can you guys see my board?
Yes.
Can you see my board? Okay. Let me hold on.
Not yet.
Does not
Okay.
start showing.
You said I can.
Yes, we can see the board.
Sorry, this is a straight line. I don't have control over this board. So this is the shape of a bell. Are we following?
Yes, ma'am.
So that's assumption, normality of error term says if you plot the error term should take this shape. Are we following? When we say normality, bell shape, what are we saying? For example, in SST 807 class, if I
It's not
administer
showing on some
examination,
of our side.
yes, who is talking? Can you hear me?
The board is not showing for everybody.
The screen must not start showing on my
If you are
end.
using your phone, it will not show.
But it's showing. It's showing on my own, but I'm using
Oh, you
phone.
are lucky. It might not show on your phone, but on your laptop, it will show properly.
My own is showing. My own phone is showing too.
Okay,
Showing on my
If
phone.
I
you
use
people are the
iPhone,
big boys using big phones now.
Ah,
So I'm trying to explain normality. Let me bring it down to discuss. So in SST
It's a big
807,
slide. We need to buy.
yes. So in SST 807 course, if I administer examination, it is expected that the performance of students in this class, that's the norm. The normal expectation is that it will take a bell shape. What do we mean? The performance of students in this class should have a norm. When they say normal distribution, this is what we mean, bell shape. What do we mean? At this side, if few people fail, it is normal. For example, the people that are talking at the background, it means they are not in this class. They just want to take attendance. So they just connected and they are maybe cooking or gisting. No problem. Those people can fall under this category. That means a few persons can fail. It is fine. Are we following? Majority, you see this shape here. Majority of people in the class should pass on average. This is it. That's this one that comes up like this. So for example, if it's a class of 90 or 100, like 10, if 10 fail and 80 pass, maybe we B or C, no problem. It is fine. Are we following? Then this one now, the exceptionally good students in the class. So maybe you have people who have done exceptionally well. In a normal distribution, majority of persons is expected that they will fall here. Then the exceptionally good persons will be here. And then the ones that think they are deceiving other people, they are not in class, but they are just connecting, they will be here. Do you understand bell shape?
Very well, ma.
Yes,
Very well.
Yes,
This is
ma'am.
the
Now, when it comes to regression, we said that the error term should have bell shape. It means that when you plot the distribution of the error term, this is the shape it should have. If your error term has this shape, it means you have met with that criteria. Is that clear?
Yes.
So let me stop and go back to my slide. So, no. Yes, and I can close the whiteboard. It's fine. What is happening? Screens. Okay. So, do we now understand the assumption of normality of errors? Do we understand this assumption, normality of errors?
Yes, ma. We do.
So, for example, that example I gave us that we had 5. If we plot those 5 errors, it should give us a bell shape. That's what it means. When we plot those 5 errors, it should give us a bell shape. So when you plot your error term and it's a bell shape, then you have met with this criteria to go on with your regression. Any question? Can we go on?
Go on, ma.
Yes.
Yes, ma'am.
The fifth assumption is multicollinearity. So we have looked at linearity, we have looked at homoscedasticity, we have looked at normality of error term, and we have looked at autocorrelation. Now, what do we mean by multiple collinearity? So in the examples that we're looking at age, income, and which other variable or social mobility, what are we saying? We're saying age and income should not be too highly correlated. That means they should not be too, the association between your regressants should not be high. They should not be highly correlated. If you, for example, if you carry out a correlation between age and income, remember the both of them are independent variables. The correlation between age and income should be low. It should not be high. If it is high, it means there's what? Collinearity, and we don't need collinearity for regression. Is this clear?
Yes, ma'am.
Yes, ma'am.
6, exogeneity. What does this assumption say? It says that your x's should not be correlated with your error term. Remember that there's E for every x. There's error term for every x for that observation. So your error term should not be correlated with your independent variable. So if you do the correlation of x and your error term, it should be equal to 0. Is that clear?
Well,
And then
with you.
the seventh, it looks like you are not enjoying this class again.
No,
It's not entering.
There's no way you enjoy statistics.
It's well, God go help us, ma.
It's well.
It's only God that will help us.
It's where. It's where.
Okay, the
Even
last
the
assumption
terminologies,
is
the terminologies are not even funny.
Fire on.
the last
Fire on.
assumption is that there should be no measurement error. Try to measure your independent, that's your x as well. What do we mean? So for example, if you want to find income of your respondent, let the respondent know if you're referring to monthly income or annual income. If you just say income, in your mind, you might be referring to annual income. In my mind, I might think you're asking me for my monthly income. You see where error comes in measurement. So you have to be explicit when you're formulating your instruments. When you're formulating your questions, you have to be clear. They should not be ambiguous, so that anybody that sees it knows that this is what you're asking. When we don't ask our questions clearly, our questions are ambiguous, that is when measurement error begins to come into our work. So we have to be careful to be sure that there are no measurement error. So you should be able to state at least 5 assumptions of multiple of regression analysis, whether it is linearity, autocorrelation, homoscedasticity, normality of errors, multicollinearity, exogeneity, or no measurement error. I've given 7, so if I ask you, it's not too much if you state 5 and explain what those 5 mean. Any question?
Oh, ma.
Questions
Hello,
like
ma.
this would be good when they are not when you don't have to do calculation. This ones would be better if you just to.
You said what?
When it comes to the questions like this would be fine, but when you have to do calculation, that's trouble.
Ma, excuse me, ma. Please, I have a request. Hello, ma.
I can hear you.
Okay, please, ma, is it possible for you to actually help us to actually clearly specify the outline of this course so that some of us can do individual research on it and study it too?
When you say specify, you already have the topic. You can go and you can expand on what I'm teaching you. So if you want to learn more regression, it's just for you to go and browse and learn more about regression.
Okay, thank you so much, ma.
So I gave you at the beginning of the course, I gave you my own outline. So I've covered I did an overview of statistics. I covered descriptive statistics. I hope you know that correlation and regression are examples of inferential statistics. That is what I'm covering. Dr. Ali is also going to give you outline of the topics that he will be covering.
All right, no challenge.
So can we move on?
Yes, ma.
Yes, ma.
Hi. When I
So again, man, please you help
God,
us.
I
Oh.
beg.
Please help us.
this one, my
Oh
hand.
my goodness. See my
I ran away.
outburst
God will
at your
make us
expression.
Because of this, I ran away from science, and I am meeting it again.
It is
You
well with
know,
our toes.
honestly speaking, let me be honest with you, Pooh. This is what we are doing is basic. Oh. I'm serious. It's basic.
This is serious.
This
Yes,
basic again.
yes, the level of econometrics we take our final year students in economics is deeper than this, is basic. So why am I saying this? I just wanted to know that there are things that are more complex than this that people have done, and nobody has two heads. So you're already setting, your mindset is already making you feel like it is difficult. It is not difficult. Yeah, it is your mindset. If you condition your mind to say that you'll be able to do it, you'll be able to do it. The people that have done it, they don't have two heads, right? So
Most
just
of
take
us,
that mindset of it is difficult. It's not difficult.
most of us here, we don't have any single orientation on calculation. So it's very difficult. Just saying it's not hard, take it. This thing is very difficult, man.
Oh
But it's
God, I'm seeing people's comments. Somebody said online mathematics is not easy in assimilating at all. Another person said chai. Oh my goodness.
Even at that,
Actually,
in social statistics, ma, we so much on this.
So powerful. So what are you guys saying?
No,
Continue, ma.
Actually,
Please continue, ma. Continue, ma. Please.
Continue,
Thank you.
ma.
Just love your teaching method. You are making effort to make it sink anyway. The examples are practical. So I think with
All
that,
right,
to
so
me,
the best I can do is just look for examples that are relatable. The truth is that statistics is not things people like, but if you condition your mind, you'll be able to do it. That's just all I have to say. So estimating regression coefficients. Some people are already creating barrier. Hey, formula, this. So it depends on how the class is. So the questions I'm going to ask, it depends on how you follow. But when you're carrying out your analysis, nobody needs you to cram all this formula, right? You just do your modeling, you throw your variables, and your computer is going to give you output. But the truth is that you must know how the computer is getting it. That's why we are coming to the rudiments for you to know how it is done, so that you know that it's not magic. This is what the computer does at the back end before it gives you your own results. Okay, so the coefficients in regression. Don't forget B0 is your intercept. I estimated using the methods of least square, which minimizes the sum of squared residuals, the difference between your observed and predicted values. So, is somebody saying something? Is somebody saying something?
No, ma. Sorry, ma. That was me. I'm sorry.
Okay. So you see, the B ones, your coefficients, the slope, I'm going to show you what starter will give you. But not to worry. So these formulas I'm giving you, apart from correlation, don't cram it. Okay, let me allay your fears. Don't cram this one. I just want to explain to you so that you understand what the computer does at the back end. We are going to see output from the computer. But anytime the computer gives you slope, what is it doing? It is taking summation of your x1 minus the mean, multiplied by yi minus the mean of y all over the summation of xi minus x all squared. Don't cram this formula. Is that okay?
Yes, ma. Okay, ma. Thank you,
Okay,
ma.
so I hope the course is okay now.
Thank you,
So
Thank you.
your x and y are the normal observation you will get from the field, of course.
It's okay. I think it's better, ma.
Okay.
Ma,
all right.
You are God, save us.
No, I'm not God. Don't allow God to be angry with me, please.
in this
So
course.
So no. God is supreme. I'm not. So your X and Y are the normal things you're going to measure. So when we talk about X and Y, even our dependent variable, I hope you know you will measure it from the field. If we're saying YX, as you're going to the field, you are measuring Y. As you're going to the field, you are measuring X. It is your slope that you will come and find. Is that slope that helps us to make prediction. So like we already know from correlation, I said X, anything that, so if you have X with that sign up, it shows that is the mean of X and the mean of Y. N is number of data points or number of your observation. This is just to tell you that this is the formula that the computer uses. So please, SST 807 class, don't cram the formula of slope. I will not surprise you with this formula so that the cost doesn't become obnoxious to you. Is that okay?
Thank you,
Yes,
ma.
ma'am.
Thank you, ma.
All right.
Thank you, ma'am.
So this is the formula for calculate. This is how the computer calculates your slope, and then this is how the computer calculates your intercept. Intercept is your beta naught. So your beta naught is the mean of Y minus the slope of x1 multiplied by the mean of x, where x bar and y bar are the means of x and y. So this is just telling you that it's not like computer is performing magic. This is what it does at the back end. So let's just end this here. But if you're advancing maybe to PhD or something, you will know all of this. So, but for the sake of this class, this is just tell us that this is what the computer does at the back end. Any question?
Ma.
No question.
Okay. All right. So let's move on. So a scatter plot can also be made so as to visually depict the regression line. Yes, Usman. Zulaiha. You want to say something? Your hand is up. Zulaiha, do you want to say something? All right, can we go on?
Yes, ma'am.
You see, when we started the simple linear regression, I gave us the regression line that y is equal to b naught plus b1 x1 plus error term. Can we remember that equation?
Yes, ma'am.
That equation is the equation of your regression line, this line. So, for example, if we want to find out how advertising affects product sales, are we following?
Yes, ma'am.
Yes, we are with you.
Now, what are we trying to do? We are trying to plot the regression line so that at any point we want to find out if the value of advertising is X, what to be the value of Y. In regression, we are trying to find this line and then we'll now use the line to make prediction. As I go further, you understand this. So this is a scatter plot with the least square line. This line is the least square line, and it is gotten after we have estimated our parameters, our variables. We'll now come and plot this line. As I go on, you understand. If you don't understand, bring me back. So now, for regression, every variable comes with either t-test or p-value. What does that do? That's the hypothesis now. The p-test or t-value, just like we have in regression, in correlation, it is possible that there will be a relationship between the independent variable and the dependent variable. Your t-test will tell us whether that relationship is significant or not. Remember I said when something is not significant, that means it shouldn't take our attention. So in regression, you might find the effect of different things on a dependent variable. As you are doing the regression, the output automatically comes with the t-value or p-value. That means it is testing the hypothesis. It's testing to let you know whether all those values you have gotten, whether they are things that should take your attention or not. So it will tell us whether they are significant or not. So in hypothesis testing, in regression, we often test the significance of the independent variables using hypothesis tests. As I go further, there's an output. We'll see all of these things. Now, hypothesis is normally divided into two. You have the null hypothesis and the alternative hypothesis. The null hypothesis is the one that always says there is no relationship. Forget, education does not, the effect of education on health is not significant. That is what null says. Null is the negative one. When we say somebody is pessimistic, it is null hypothesis. It's always seeing bad thing. There is no, it is a no effect hypothesis. Why the alternative hypothesis is there is something, right? So the null hypothesis says that your B1 is the same thing as 0. That means there's no significant relationship. But your alternative hypothesis says your B1, when we say B1, we're referring to the slope or the what's coefficient. Your alternative hypothesis is saying that yes, your coefficient is different from 0. When something is different from 0, it means it is not 0. That means it is significant. But if it is equal to, normally if I ask you that how much do you earn, you say your income is 0, is it significant? I'm answering the class.
No, it's not significant.
So when
No.
something is equal to 0, it's not significant. Are we following? So when our intercepts, our slopes or coefficients are equal to 0, that's what null hypothesis says. So if you have found a regression, you say, even if there's a relationship between age and education, the null hypothesis will say it is not significant, while the alternative will say it's significant. So our p-value or t-value will tell us whether we'll accept the null hypothesis or we'll accept the alternative hypothesis. Is this clear? See, when I go to the results, when I show you results, I'll show us practical results. If you don't understand, then bring me back here. Because some of these things is when you see the results that they will now start making sense to us. Is this okay?
Yes, ma.
Yes, ma.
The response is cold.
Yes, ma. Yes, ma. Yes, ma.
Yes, ma.
Yes, ma. For almost 20-something minutes now, network has been my problem.
It's just a network. I mean, the calculation.
So, Bam, that's an exogenous factor to me. It means that it's something that I cannot control, right? I can't control your network, so I'm sorry about that. Now, we also have
No
standard
problem.
errors. Every variable comes with standard error. Standard error measures the accuracy of your estimated coefficients. We are saying, don't worry, when we look at the example, you see. But just know that standard error measures the accuracy of your coefficients. And we are saying the smaller your standard error, the more precise your estimate. What are we saying? If you tell us that age affects education, if the error is big, you are saying that you are not too sure of how age affects education. But if the error is small, it means your confidence is higher, isn't it?
Yes, ma.
Yes, ma.
It is.
So this is the formula for standard error, right? You don't need to cram it again. Please do not cram it. We are in this formula, n is your sample size, k is the number of predictors. When we say number of predictors, using that first example of multiple linear regression, we had 3 predictors. When we say predictors, we're referring to independent variables, isn't it? So we have 3. So in this formula, your k will be that 3. It will be the number of your independent variable. So remember I said they have different names, so they can use a name that you don't understand. So it's important to know their names. So for hypothesis testing, your beta is greater than 2 and than 2 times your standard error. If your beta is greater than 2 times your standard error, you reject the null hypothesis. Again, these are all the things that happens at the back end of the computer. Please do not bother yourself with it. But it is good, you know. So there are 2 things we use in hypothesis. There are 2 things we use, whether to accept our null or reject or to accept. So if we're accepting null hypothesis, automatically we are rejecting alternative. I hope you know there are 2 sides of a coin. If you accept alternative hypothesis, automatically you have rejected the null hypothesis. Are we following? You can't accept both at a time.
Okay, ma. Ma, we're following.
So we use t-statistics and p-value to help us know whether to accept or reject hypothesis. So t-statistics is used to determine whether an individual regression coefficient is statistically significant or not. So this is your formula for t-statistics. A high absolute t-value suggests that the independent variable is significantly associated with the dependent variable. So critical value for a 95% confidence level, the critical value is typically 1.96 for large sample. This 1.96 is even 10%. 2.56 indicates significance at 1% level. So again, don't bother. When I go to results, all these things I'm saying, when I go to the practical results and you don't understand, we can come back to explain these things. So p-value, I said it's either you use, so I gave us the range for p-value in our slides. So it's either you use p-value or t-value. It's easier to use p-value. T-values can be confusing to people most times. The p-value indicates the probability of observing the data if the null hypothesis is true. A p-value below 0.5 generally means we reject the null hypothesis, indicating that the variable significantly affects the dependent variable. An example, if the p-value for education in predicting income is 0.03, what does null hypothesis say? So for example, in this example, we said education predicts income. What do you think the null hypothesis will say? The null hypothesis will say that education does not have any significant effect on what? Income. Are we following? I said null hypothesis is the negative one, the one that says there's no relationship. Yeah, is the hypothesis that always sees something bad. So if we're predicting, we're using education to predict income, null hypothesis is say, even if you find a relationship between education and income, it is not significant. But the alternative hypothesis will say it is significant. Now, what this p-value is saying is that when your p-value is below 0.05, you always reject the null. It means there is a significant relationship between any of the variables you're looking at.
Ma, do we need to cram this one? Do we need to cram?
You must not p-value. So in an earlier slide, I give us a range of p-value. So for example, I can give you a result and I ask you to tell me the level at which the different variables are significant or not. So at least no p-value. If you are not knowing t, if you are not cramming formula for slope and intercept, at least you should know your p-value. Confidence interval.
Thank you.
Confidence interval provides a range of value within which the true coefficient likely falls, right? So for example, if we work the confidence level most times are often 95% or 99%, and indicates the probability that the interval will contain the true population parameter.
I'm a fleet, you can
Fire! Fire, you're not even hiding it. You're just speaking tips so that I don't understand what you're saying, right? So when we say confidence interval, if you're carrying out regression, you must set your confidence interval. I think the norm is 95%. What are we saying? We're saying that if you repeat, confidence interval is saying that if you repeat this thing you have done 95 times, you will get the same results. Are we following? So when your confidence interval also gives us confidence on, or gives us leverage to rely on your results. So we say confidence interval indicates the probability that the interval will contain the true population parameter if we were to repeat the sampling process many times. Let me go to results. I think from that one you can understand better. R square. These are all the things you interpret in your regression. R square measures the proportion of the variance in the dependent variable that is explained by the independent variables. So for example, when you do your regression, normally your output comes with R square. If your R square is 75 or 0.75, 0.75 means 75%, it means that the variables you have put into the model explains the variability in your dependent variable by 75%. It means there are other things that explains the dependent variable that you have not put in, and those things that you have not put in are 25%. Are we following?
Yes, ma'am. Absolutely.
Yes, ma'am.
The R-square value typically ranges from 0 to 1. So any R-square more than 1 is no longer R-square. A value close to 1 means that the model explains most of the variable in the dependent variable. That means it's a good model. An example, if R-square is 0.75, that means 75% of the variation in the outcome can be explained by the predictors. That means you are putting 75% of the things that affects or that explains the dependent variable. 25% has not been put. That's simply what your R-square tells you. Now, adjusted R-square. Adjusted R-square accounts for the number of predictors in the model, providing a more accurate measure of model fit when multiple variables are involved. So, for example, if it is simple linear regression, yes, we can look at the R-square, but the adjusted R-square gives us a more accurate measure compared to the R-squared. Don't worry, I can understand what people are feeling, but don't worry, your fears will be allayed. Just follow me in good faith.
Amen. Amen, ma. Amen.
Just follow me. Your fears are going to be allayed. S-statistics. S-statistics test the overall significance of the model. So your t-test and p-value test the significance of the variable, while S-statistics test the significance of the whole model. That's the whole variable put together. Is it actually significant or not? That is what your S-statistics does. So a significant S-statistics. Yes, is somebody saying something? Is somebody saying something? If you are not, please kindly mute.
Is God way Sunday making noise, man?
Okay, are you saying that I'm blocking the slide? Somebody said you're on the screen.
Yes. Yes, ma. Yes, ma. You're on the
Okay,
screen.
hold on. So sorry.
Yes, yes.
All right, let me do that again. Sorry for that. So I shouldn't appear now. Can you still see me?
It's
No, we
better
can't
now,
see.
ma. It's better now. Thank you.
It's okay now, right? So I said your p-value or your t-test test the individual significance of variables, each variables, while your S-statistics test the significance of the whole model. Your S-statistics tells us if your model is a good fit for the data or not, right? So now let's look at this example. All our fears will be allayed. Forget all those big grammar I've been talking of. This is an hypothetical data. When we say hypothetical data, we have formed it. It's not like it's necessarily in existence. Is that okay?
Yes, ma'am.
Yes,
Yes.
Okay, ma.
So now, though, everybody's going to understand now that we have data to explain regression. Now, suppose we have the following data that represents the relationship between our studied and exam scores. So our studied is our independent variable, exam scores, our dependent variable. I will have this data for 5 students. Can we all see the screen?
Yes, ma'am.
Can I move on? So now, if you don't understand, you draw me back. All those grammar I'll be speaking, this is the time where we'll see the practical application. Now, we have to calculate means. Forget all this, any calculation that has to do with regression, at least for this class. Since people don't like statistics, forget it. But these are the things that the computer does at the back end. It will calculate the mean of X and it will calculate the mean of Y. Are we following?
Yes,
Yes, ma'am.
I will show you what. So all these things now that you are seeing, all this calculation, you won't see it. Computer will only give you your final results. We are going to get them. So using the formula for slope, this is how you calculate it manually. Eh?
Okay, ma'am.
I can only ask you to do this in assignments where I know you will have the formula to look at, but don't bother. I won't bring something like this in exam to scare anybody. Is that okay?
Hallelujah. Thank you, ma. Thank you, ma.
Thank you, ma'am.
Praise God.
That does not mean you should not study.
Yeah,
We
no,
will.
we are
We
already
will.
So there's an
we are
assignment.
studying.
Everybody must even do it. There's an assignment at the end of the class that everybody must attend to. All right, so this is what the computer does at the back end. Your N is your 5 because we're looking at 5 observations.
Yes.
Yes.
Is anybody saying something?
Please continue, ma. Please.
Now, in finding the slope, your coefficients, remember that this is simple linear regression. So we're just going to have one slope, right? So in this formula, your n is 5 because we're looking at 5 students. Summation xi is the summation of all the x, literally. So you do 1 plus 2 plus 3 plus 4, it will give you 15. Summation of y, it's this is the search kit I was telling you that when you're modeling, you tell us. So in your own model, if you're going to the field to collect data yourself, your own will be I. If you are using already existing data and it is time series, your own will be T. If you're using panel, your own will be IT. The importance of putting it is that at a glance, when we look at your model, we'll be able to tell the kind of study you're doing. You're doing either a cross-sectional study, you're doing a time series study, or a panel study. Now, this is literal addition of your Y. So remember, this is outcome, your grade. So you do 50, 55, you add it, you get 320. Now, this summation XYI,
Yes. Summation XYI
is the multiplication of X and Y, and then you sum it up. So, for example, the first X is 1. The first Y is 50. So this dot, I hope you know dot in math means multiplication. This one does not mean 1.0. There is space. This is 1 times 50. This is 2 here. 2 times 55. 2.55. That's what it means. Here is 3 times 65. 4 times 70. 5 times 80. When you multiply, board math tells us that we'll attend to the things in the bracket first. So multiplication of board mass is bracket of division, addition, and subtraction. So we'll handle what is in the bracket first. So 1 times 50 is 50. 2 times 55, 110. 3 times 65, 195. 4 times 70, 280. 5 times 80, 480. When you add everything up, it gives you 1035. So this summation XYI is 1035. Is somebody saying something? Can you now? Is it Fayam that is talking?
Mute your this thing.
Hey, good.
All right, so we all know how we got summation X. We have plenty teachers and you're saying it's difficult, but you're not even listening. So we all now know how we got the summation of XI multiplied by YI. So whether it's a dot or it is like this, there's an invisible multiplication sign between X and Y. Now for summation X1 squared, we're going to square each of the x's and add it. That's what it means. So 1 square plus 2 square plus 3 square plus 4 square plus 5 square, it gives us 55. So this is how the computer, or how you are going to get the values that you're going to impute into these places before you now get your P1. Is that okay? So when you get all those values, you impute them and you divide. Your B1, which is your slope, which is your coefficient, is equal to 7.5. Are we following? If we have gotten our slope, then we can now go to get our intercept. To get our intercept, it is the mean of y minus slope multiplied by the mean of x. We have already gotten all those things in the previous slide. So we're going to impute them and get our B naught. Now, this is how we write the regression line. Who is talking now? Please, even if it's difficult, interjecting does not make it easier, right?
Sorry, ma.
So now, in writing our regression line, I'm already tired, honestly. In writing the regression equation, the estimated regression equation, when you are writing regression equation after you have calculated, you can see that we're not writing normal y. This is y hat to show that we have estimated this regression. So y hat is equal to 41.5 because our intercept here is 41.5. So y hat is equal to 41.5 plus our slope is 7.5, 7.5x. Are we following? So this is our regression line. Now, what do we use? Remember I said initially that we use regression to predict. how do we do the prediction? So for example, we can now use this equation to predict exam scores based on hours studied. So if a student studies for 6 hours now, we can now determine what the student score will be. Any student that studies for 6 hours will come out. So this 6 hours now is the X. We'll say the outcome, which is going to be the score Y, will be 41 points. So what this line is saying is that whether a student studies or not, the minimum score the student can get is 41.5. Are we following?
Yes.
Yes, ma'am. Yes,
Remember,
ma'am.
we said that your B naught is the value of Y when X is equal to 0. Now, since we have gotten this line, we can use it for prediction. So any student that studies for 6 hours will get a grade of 86.5. All we need to do is to slot in 6 here. So the person's grade will now be 41.5 plus 7.5 times 6, which gives us 86.5. So we can now use this to make prediction that if you study for 6 hours, on average, you're going to get an A. You get a 6. So this one now, even the results we're getting, this prediction we're doing is on average. You know, when we say average, some people can be below it, some people can be above it. But it's just giving us, you know, an estimate of what it can be if we use our regression line. Now, so hypothesis testing. So this is how you calculate your T statistics for this particular example I've given. And then, so for example, in this one, T statistics is 15. If T statistics is 15, it is greater than 2.56. We are saying it is significant at 1% level. So we say that of a truth, our study, the number of hours you study significantly affects your outcome. Now, if you do your project, this is what you will get. The starter I've been telling you, this is what the starter output looks like. Are we following? All those ones I've been talking, they are manual. Of course, we don't expect you to do manual in your projects. You are going to go the route of using a software. Now, if you use software as an example, you see all what we calculated manually. This is how when computer calculates it, this is the result computer is going to give us. Are we following? Now,
Yes.
what you have done is to regress exam score, which is your Y, on hours studied. In starter, the first variable you put after your syntax is your Y. Y, this is X. So we want to regress Y on X. Now, this is what your result looks like. You see what I was telling, a number of observation is 5, right? And then our F statistics is 22.5. Now, this is the significance of F statistics. Now, the probability of X statistics, the p-value is 0.0096. This one, if you look at the range I gave you, is significant at 1%. It tells us that our F statistics is significant, that this model is a good fit. Are we following? When we say the model is a good fit, it means that, yes, you can truly use our study to predict outcome in an exam. Now, this is our R squared. What this is saying is that our studied predicts your exam score by 98.6%. Right? So the only thing that affects exam score that we have not put in is just minor 1 point something percent. So you can see that your adjusted R square is also not far from your R square. So these are the things you will be looking at. The other things you can ignore. Now, going straight to our results, this is coefficient. This coefficient is our B1s. Are we following? Is your B. Your constant, that B naught, see it here, 41.5. You can see constant, 41.5. Can you see it?
Yes,
Yes.
Now, this is what is important for us. What this 7.5 is saying is that our studied, first of all, has a positive relationship with exam score because it is positive 7.5. Are we following? Remember when we calculated it manually, we also got 7.5, isn't it?
Yes.
Only Abu Emmanuel is answering me.
Yes, ma. Yes, ma.
yes, ma'am.
So the first thing we can pick from this result is that our study has a positive relationship with exam score. What does it mean? If you increase hours studied by 1 unit, exam score will increase by 7.5 on average. I was expecting that you people will write this because there's nowhere. Okay, so I have it in the slide, so it's still fine. Now, this is standard error. Remember, we say the smaller your standard error, the more reliable your coefficient is. So in this case, our standard error is 0.5. That means the error in what we have done is 0.5. You can see that the error for the constant is greater than the error for our coefficients. Remember, I said we do not actually explain the constant, but this is the standard error I was talking about. This is your p-value, your t-value. When t is greater than 2.56, it is significant at 1%. I told you that t will be difficult for you, so let's use p. Now, remember what I told you, that the easiest way for you to know when something is significant at 1, 5, or 10% is to multiply it by 100. So in an exam situation, when I bring something like this and ask you to tell me to interpret this result, in interpreting it, you will tell me whether it is significant or not. What do? You carry this your p, multiply it by 100. If it is less than or equal to 1, you will now say that this is significant at 1%.
Yes, sir.
Hello, everybody.
Yes. That one has been taken.
But we are here.
We are
here with
following.
you.
So
We are
the fact
here.
that there's a relationship between our studied and exam score, we need to know whether it is significant, and it is either use your T or your P. And the easiest way for you to know is for you to carry your P value multiplied by 100. If it is less than or equal to 1, it is significant 1%. If it is greater than 1 but not greater than 5, it is significant at 5%. If it is 10 or from 6 to 10, it is significant at 10%. Then this is our confidence interval that we talked about, right? So from 5.90 to 9.09. So we are saying that if you repeat this criteria, this research we have done, we are confident that this coefficient will still lie between 5.9 and 9.0 if you repeat it 95 times. So you can see that 7.5 lies between these two. So this is our confidence interval. Somebody else might do it. It might not be 7.5, but it will fall within this range. Is that clear?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
All what I've said, this is interpreting a regression coefficient.
People are just
Right? So,
asking yes, ma'am, all the time.
somebody saying something.
We are saying that Abu is just answering. We'll catch him to teach us this thing.
Manasseh, let's hear you.
He bring Emmanuel back. He will do observation.
I understand that the percentage gotten in that calculation, the 5.9, does it mean that the values cannot be approximated to make it maybe 5 point, maybe to make it 6?
What are you referring to?
I'm referring to the percentage of the coefficient.
Open your mouth and take.
Percentage of coefficient. Is it confidence interval you're talking of?
Yes, the confidence interval. After calculating using the p-value to calculate, that is multiplying by 100. And then we have the 95% as the coefficient.
It's not this multiplied by 100 that is giving you this, so you are mixing things up.
Okay.
If you multiply this by 100, if your answer is from between 0 to 1, we are saying this thing is significant at 1%. This one is saying different thing. We are saying that if you repeat this experiment 100 times, we are confident that 95 times your own coefficient will lie between 5.9 and 9.09. You can say that this our results is in between this range. So our confidence is saying that if you repeat this experiment 100 times, 95 times, your result must be between 5.9 and 9.09.
Exactly. So the question is, can this not be converted? Maybe this 5.9, make it 6.
Why do you want to convert it to 6? 6 also lies within the range now. We are saying it will not be less than 5.9. 6 is in front of 5.9. 7 is in front. 8 is in front. It's not for you to change to change this range.
All right. Thank you so
Are you
much.
following?
Yes, yes.
So the value of B tells us the amount by.
I have a
Is somebody
question,
saying
my
something?
friend. I have a
Okay,
question for you.
I'm listening.
My question is, after
Swallow
getting
it.
the
Don't do this in the way.
okay, hello,
Who is that person?
hello, ma. My question is,
Abu, I can hear you.
thank you, ma. After getting the P, now I want to know the value, the regression value. That is 0.001 multiplied by 100, and then
What
if,
did
for
you get?
instance, I get 0.1, I think so, 0.1.
0.1 is less than 1. So that tells you that this hour studied is significant at 1%. That's just what it's telling you.
Okay, and then if I multiply it again by 2, I'm most likely going to
Why are you
get 0.
multiplying it by 2? Did I ask you to multiply by
Sorry,
2?
multiply by 100. 0.02 multiplied by 100.
Where did you
Multiplied
see
by
0.02?
Okay, the question I want to ask that is kind of complicated for me. I want to know, like, after getting different value, for example, if my value ends at 5 or maybe like 10, which one actually stands positive? Or is there no difference
Your
to the
question is
answer?
not even clear in the first place. You can only for each so this is your independent variable. For each independent variable, you can have only this T and P. This is your T statistics, this is your probability level. This T
Yes.
and P, they are saying the same thing. If you don't understand T, use P. P is only telling us whether this variable is significant or not. You cannot have more than one P. So I don't understand when you say if you have different values, which one? You can only have one P. You can only have one P for one variable.
All right, thank you.
All right, so going further is the explanation. Remember I said that a unit increase in hours studied will increase your exam score by what? 7.5%. If it was multiple linear regression, you will say why holding other variables constant. Are we following? But because it's a simple linear regression, we are just explain it directly. But if it were multiple linear regression, you see other variables, other covariates here. So when you're interpreting, you say a unit increase in this will affect the y by this, while holding other variables constant. So all of these are the explanation. When you read again, everything I've said here, these are the explanation here, right? What are the limitations of regression analysis? As good as regression is, we can use it to make predictions, it still has some limitations. Overfitting. When the model is too complex, it may fit the training data well, but perform poorly on new data. Remember that we are using regression to make prediction. Sometimes when it overfits, when your R square is almost perfect, your F is perfect, your model would have fitted well, but it might not be able to perform, it might perform poorly on other new data. And sometimes it can underfit when the model is too simple. It may fail to capture important relationships in the data. When we say overfit, when you are using it to predict a new one, if it doesn't have all the variables that you have imputed into this model, your model is going to perform. When we say your model, that's that y you will get at the end of the day. You are looking for the regression line, your y hat. Your y hat might perform poorly on new data. When it underfits, your y hat, your regression line might also perform poorly. Now, causation versus correlation. Regression can identify associations, but it does not prove causality. Remember what I told you, that correlation does not show causality. When we say causality, it does not tell us that this is what causes this. So it's the same thing with regression. Regression also identifies association. It does not prove causality until you meet up some additional assumptions. So now, for regression, one thing I forgot to mention at the beginning is that for simple linear regression or multiple linear regression, when do you know when to use multiple linear regression? Because there are different types of regression. Remember when I was telling us that our ability to identify the type of variable our y is has solved 50% of our problem. Now, when we come to this our example, here, see our Y. Our Y is our exam score, isn't it? It is Y that tells us the kind of model we are going to use. I want to ask, is this Y quantitative or qualitative?
Quantitative. It is
Hello.
quantitative.
Is our Y quantitative or qualitative?
It's
Quantitative.
quantitative. It's quantitative, ma.
So even in the quantitative, is it discrete or continuous?
It's discrete,
It's
ma.
Discrete.
Okay. So we use so it is discrete, right? So we use multiple linear regression when our Y is quantitative. Are we following?
Yes, ma'am.
Are we following?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes,
When
ma'am.
our Y is quantitative, and I'm going to explain. So regression, there are different categories. So at your level, just take it that when Y is quantitative, we use multiple linear regression. But when you are working with your supervisors, there are some model now differentiates between count variable, continuous variable, discrete variable. You will solve all of those problems with your supervisor. But at this level, if your variable is quantitative, you can use multiple linear regression. Now, let's go to logic regression. We can use logic regression when our Y, that is your dependent variable now, has two categories. When our Y is categorical, what do I mean? So for example, if this Y were to be gender and we code man as 1, woman as 0, man as 1. So if this person was a man, you might have 1 here. If this person was a female, you have 0. If this is man, you have 1, female 0. In that way, our Y is categorical and it's binary. It has two categories. It's either it is 1, that is male, or it is female, that is 0. Do you understand when I say two categories?
Yes, ma'am.
Yes, that one is good.
Yeah.
This one is clear, Abi. So when your Y is binary, you use a logic regression. So logic regression is used when the dependent variable is binary. So for example, if you have asked a question that the response is yes or no, you just have two categories, or the response is success or failure, or the response is male or female. What we're trying to say is that as long as the response is only two categories, then you can use a logic regression. If your response is binary, that's two categories, you cannot use multiple linear regression. Multiple linear regression is for quantitative value. Remember that this response that is binary tells us that it is categorical. That 1 or 0, it is recoding. You will get to understand what we mean by recoding as you advance in research. But the main thing is that the response is 2, yes or no, success or failure, good or bad. As long as your response is 2, it means that you're using a logic regression. And when we say response is 2, remember that we're referring to Y. It is Y that tells us the kind of model that we are going to use. Is this clear?
Okay, ma'am. Yes,
It's only Jennifer answering me. Abu, I'm not even hearing your voice again. Fire.
It is clear.
Digba.
It's clear, ma. It's clear, ma.
All right. So this is what we have. This is the equation for logit. You really do not need to cram this. But when you're modeling in your work, you must model. You must show us your model for us to be sure that you know what you're doing. So this is the assignment I have for us. Wait now.
Chai.
Why are you people shouting chai now? And you are submitting it on the 21st. But the good thing is that I heard that there will be no lecture tomorrow. They are shifting the lecture for tomorrow to Saturday. So you can actually do it tomorrow. So using the following data, this is the data. And I've indicated what your Y is, your dependent variable. I've indicated what your X is, your years of education. This is what you're going to do. You're going to calculate the slope, and you're going to calculate the intercepts, and you're going to fit this regression line. After you do that, you're going to interpret the coefficients. Then you're going to get a different line. Then using this model, predict y when x is equal to 10. Then interpret the meaning of the slope in this context. You're going to submit your assignments to my email, obekwa.hepzibah@um.edu.ng. Any assignment that comes after 21st will not be marked.
Right. Thank you.
So
There is
to do this
God.
assignment,
Stop telling you.
wait, to do this assignment, all you need to do is to go back here. Are you following?
Yes,
You
sir.
see, it's just that my own is longer than this. Your assignment is longer than this example I've given you. But if you follow this step of this short example, it's exactly what I expect you to do for the assignments. Are you following? So the question I'm supposed to ask you in the exam, I'm asking in assignments where you have access to look at the formula, because in the exam you don't have access. So is it not better we do it as assignments than it coming up in exam?
But you see how the thing is giving us headache. At least you should give us 1 week interval so that we can try to generalize these formulas. 21st is too short for
When
us.
you say generalize the formula, what do you mean? I've already given you the formula. Which formula are you going to generalize? See the formula here now.
I say
Seconded
internalize.
by me.
I didn't say generalize. I say internalize them. We should be able to do the work, rework it, and at least get used to the formula. Otherwise,
So
you
what
see
is
how we're
today's date? Today is just 17th. You have 18th, you have 19th, you have 20th, up to 21st. The truth is that after this week, you're going to have another course, right? Now that it is hot, the zeal is here. This is the best time. So tomorrow now, it's we said there's no class tomorrow. They are suspending tomorrow's class. Why not use tomorrow? Go over all what I've taught you and then try it. Then you can also compare with your friends. Oh boy, this is what I got to. What is your B? What is your B naught? What is your beta 1? What is your beta naught? What is your mean? What is, right?
Should we handwrite the assignment?
No, you're submitting it to my email. You mean you're going to type, right?
And excuse me, ma. Excuse me.
Yes, I can hear
You
you.
know, is the table for the assignment? I didn't get it. Like the first
I've already
three.
sent these PowerPoints to you now, so you have it already.
Okay.
That's the PowerPoint
Alright.
I sent earlier. The assignment is there.
Okay, I've not opened it. That's fine. Thank you.
Okay.
Sorry, ma, you said you should type it. And did you say we should type?
Yeah, yes, now our class is virtual class. Why will you see me to submit now? Maybe somebody is in Sokoto. How will the person in Sokoto submit?
You have to type now.
Yes.
Mommy, how can I handwrite it and scan it and send to your email?
My brother, if you are doing virtual class, you should be, in fact, you should be able to. I'm thinking of giving you another test using either Kobo Collect or Google Form. So this is the
Sorry.
list. If you are doing virtual class, this is the list. Typing your assignments and submitting is the list thing that should be your problem.
All right, ma. Thank you.
Any other question?
Yes, ma. Excuse me, ma.
Yes.
So did you say that this one is coming out in exam?
Oh. You want me to bring it in exam?
Madam Precious.
No. This is your
Precious
exam.
want to get the
Assignment.
You want to use Expo?
Game guy, your hand is up. What do you want to say? Game guy, do you want to say something?
Yes, ma'am. My own is to appeal for 1 week so that the assignment will not help us to digest the work more. Because as
My
I
brother, I will not take it to 1 week. Now that you know that you're submitting 21st, you must go back and understand all that I've taught you. So let me show you people how, since I'm asking you to type the assignments, let me show you how it's easy for you to type formula on MS Word. Is that okay? Because if you are typing the assignment, it means you will also type your formula. I hope you know.
Yes, ma'am.
Okay, so let me show you, just tell you that it's not like I want anybody to fail or to make anything difficult. But in you doing this, you're also learning other skills. Those that don't know how to use MS Word will use it. Now, I'm going to teach you something new that you use to type formulas in statistics or economics, as the case may be. So let me go to MS Word and show you how you type your formula. So when I say submit to my email, I expect you to submit a document, you attach it and submit. So you write your name, if you have reg number, if not your application number, and submit. Anything that comes after 21st, I'm emphasizing again, I'm not going to grade it. So let me go
Sorry,
to
ma. Hello, ma.
yes.
I'm having challenge of network here. I couldn't follow you people down now. But what I'm pleading now is that can we have a document on this topic that will help me to be updates, ma?
Yes, sent it.
SST 807 class. I have already given you my slide. Which other documents? Do you
He
want
said
me
he's
to
just
give you?
coming in now, so it's not his fault.
Okay.
It's because
So
of
let me show
network
you how
challenge.
to type formula, or else your formula will be scattered, and it's important. So you're going to be writing your thesis. You should know how to type formula. So to type formula, can you see my screen?
No,
Yes.
no.
Are you seeing
No.
MS Word?
No.
No, not
See
yet.
your face.
Okay, so I didn't share it. Hold on. Let me share. Okay. So can you see the MS document?
Not yet.
Yes.
Okay, we can see.
Okay. So when you want to type formulas or formulae using MS Word, you come to edit. So it depends. Sorry. Sorry. I also do not know the version you are using. So you see all this tab here, your file, your home, insert, draw, design. Are you seeing?
Yes.
Yes,
So you come to insert. There's file, sorry. There's file, there's home, insert, draw, design. So click on insert. Are you seeing me?
Yes.
When you click on insert and you want to type a formula, you will now come to this place where you have equation. Can you see my cursor?
Yes, ma'am.
Then you click on it. So this one will appear. Can you see? So for example, if you want to type B naught, are you seeing me? You want to type B naught is equal to something. B naught has a subscript. You have B, the main character you want to type, and then there's a subscript called naught. Are you following?
Yes.
So to type B naught, you come to this place where you have scripts. Are you seeing scripts?
Yes, ma'am.
You click on it. When you click on it, you don't need this first. This first one is if you have a superscript, but your formula has a subscript, not a superscript. So you come here, click on this. When you click on it, you now take your cursor to the first one. If you're looking for beta, you click here, you will see beta here. So this is beta. You come back, 0. This is beta 0. Then equal to sign. And then you continue. Once you type in this box, your formula will be together. But if you do not type it in the box, when you are submitting it to me, it will come as something scattered. Are you following?
Okay. Okay,
So
ma.
always type your formula using this equation editor. Anything you want, just play through this. You will get all what you're looking for. If you want to do equal to, so for example, our beta knots, if it's equal to, you will put this. What you need to put up, you put them up. What you need to put down, you put them down. I'm talking, others are talking. Well, I've shown you how to use equation editor.
So we are taking egg.
Is this clear?
Yes,
Clear.
So please use equation editor to type your formula. Don't just type, don't go and look for B. Remember, this is not B, it's beta. So come here and look for the alphabets. Your Greek alphabets are here. So let me go back and start again. Right? So let me come down. You go to insert, you click on equation, and then it will come up. This place here is where you find all those alphabets you're looking for, whether it is beta, it is theta, or what have you. If you want to do a fraction, you click here. You will get the interface where you pick the option you want to show. If it's a subscript, you come here. If you want to use square root, you come here. You want to use integral sign, you want to use summation sign, you come here. You want to use brackets, you come here. Everything is here. So you can play with it and then you get what you're looking for. Any question? Any question? Let me hide my face because at this point, this class, they don't want to
Yes,
see
ma'am.
my face again.
Sorry. I
I'm all yes. I'm all yes.
okay. I
Just
was
pray
locked
for us,
out
man.
by my network, and when I came back, I discovered that an assignment has been given.
Yeah.
I can't tell. Maybe the assignment is to be published on the meeting so that some of us that didn't see it will be able to see it.
So my
So I
brother,
was
the slide I dropped on WhatsApp has all the information you need. The assignment
Thank
is
you.
going to be submitted to my email. My email address is there. Everything you need is there. Even if you have missed the class, you can plead with Mr. Okpanachi, the PTA, to quickly give you the recording for this class. But even if you don't get the recording, you have the slides to help you. And you can chat me up. If I'm free, I will respond and explain again to you. But if I'm not free, but I'm actually very busy this period, then
Okay,
that is
ma.
what it is.
Thank you very much.
Okay, ma. Thank you, ma.
Plus, if it's okay
Yes,
for me to say,
Manasseh, your hand is up.
I was the one asking question, so I think I'm okay.
Okay, so
From
I
there.
think we can call it a day now. The hour is now ungodly. We have crept into an ungodly hour so that we can go and
Thank you
rest
so
and
much.
then continue with other businesses in our lives. So thank you all very much. Dr. Ali is going to
Thank
continue with
you
your class on
very much,
Thursday.
man.
If there are questions bothering
Thank you
you,
very much.
you can chat me up. But if I don't respond, it doesn't mean I'm ignoring you. I'm actually very busy. I'm doing a lot of things. But it's even better if you can see me physically. And so for those who are in Benue, but if not, don't forget that we're going to have revision. So don't be scared. Anything that is bothering you, when you come for revision, you can come and ask and we'll attend to it. If it's something we can talk on WhatsApp, no problem. You can drop messages anytime I'm free. I'll respond to your messages, either using voice notes or any method I deem fit. So thank you guys. It's nice
Thank you, ma.
interacting with your
I will chat
class.
you on WhatsApp, ma.
Thank you very
Somebody
much.
don't ask me this night though.
Thank
No,
you,
not
ma.
this night, ma. I say I will
Excuse
chat
me,
you
ma.
on WhatsApp.
Thank you,
Yes,
ma.
Excuse me, ma.
For
yes.
more elaboration, ma.
Mm.
Thank you, ma.
Okay, ma.
God bless you.
Ma, please confirm about tomorrow's lecture. No lecture is holding tomorrow, right?
For MSC.
Hello, ma.
Yes.
MSC.
Are we having lecture
Okay.
tomorrow?
No lecture.
No, the HOD told me
All
that
right, ma.
they are postponing tomorrow's lecture to Saturday.
Okay.
So lectures will continue Thursday, Friday, and Saturday.
Okay.
Right,
Don't
but so
Friday.
just to let you guys know, in case you think that there's something that is still difficult, so we can schedule a class maybe on Google Meet off our normal schedule. So we'll look for a time that is convenient for me and for you guys. I can always explain if you think that things are too difficult. So the moment I have 1, 2, or 3 persons saying something is difficult, we can schedule time for us to explain again. I can understand if all what I've said is too much for you to take at once. Yes, I understand. But when you go
Yeah.
back, it's not as difficult as you think, right?
Okay.
Okay.
Yeah, so my WhatsApp is opened. I've been posting on your WhatsApp platform. That's my number. I posted your exam timetable. I posted my
Yes.
materials. So
I
that's
see.
my number. If there's anything
My
that is too
bro,
difficult, I'm your sister. So
actually,
please feel free to reach out.
Okay, ma.
the
Thank you,
assignment
ma.
submission
Thank you, ma.
is too brief.
You said what?
The date for submission of the assignment is very brief.
You know the problem. It's not like I cannot extend it, but the more I extend it, the more problem it is for you. The next person, you don't know the assignments the next person is giving you. You don't know what the next person is coming with. So make hay while the sun shines. Why not just deal with it and let it be gone, right? So you don't know what Dr. Ali is coming to give you. After Dr. Ali, you have another class next week. You don't know what the facilitators are planning for you to do. Why not just handle this so that it goes?
Okay.
It's all right.
Are we
Okay,
following?
we'll try. We'll try.
In God we
But if
trust.
there's any particular reason why you cannot meet up, you can chat me up.
Okay,
Let's
ma.
But
reason
because
together,
the
please.
whole
Okay,
of
ma.
tomorrow we'll be sympathizing and we'll be sympathizing with families that lost their people in Yellow Water crisis. The whole of tomorrow will rest. it's not good that people are
It's not.
President
nowhere
Tinubu
to
is
And it's
coming
capture
to
why I
people.
did the
Makurdi tomorrow.
assignment.
Yes, it's true
It's
now. It's not
okay,
He's
something
going
my
to
to
do
brother.
in
laugh
You see,
Makurdi
about.
have
tomorrow.
Thursday and Friday.
Okay.
Oh.
Right. Okay. So thank you guys. Thank you everybody. It's nice having you guys. So see us later. See us during exams or see us during
Good
revision.
night,
Thank you. Bye
man.
bye.
I'll see
Good
you
No,
night.
we
soon.
still meet.
No.
We
All
meet
right.
tomorrow,
Bye
ma.
bye.
We
Okay.
just pray the next
See, you're
lecturer
my
should be like
supervisor, so I'm seeing
to
you
be
soon,
blown like
man.
you.
Class
Who is
Because even
talking?
you is not easy.
chat me on
Who
your
said
WhatsApp,
I'm her
please.
supervisor?
I'm the one.
Who is that?
Abu Mimi Domo.
Yeah, I'm just
Yes.
knowing. All right, no problem. We'll meet now. It's okay. Good night.
Yes. Thank you,
Okay,
ma.
bye-bye. All right,
Bye.
okay. Bye.
Hello, class rep.
Tell me, staying good night, doc.
Abu.
Class rep should do what? See, everything this night is bitter. Let's go and rest.
Please
Abu
see the
Emmanuel.
number. I said Silas. This is Silas. I
Abu
requested for
Emmanuel,
number
end the
then.
meeting, please.
Please send
not
me
going
the
to kill
number
me again. What is bitter there
on
about
that
this
Abu
on the
night?
Emmanuel, end
WhatsApp.
the
On the
meeting. You are
WhatsApp.
the
On the
host.
WhatsApp.
We
On the
are
WhatsApp.
tired.
Okay, wait.
Yes.
All right.
Guy,
Yeah.
let's go and shoot ourselves at the WhatsApp, I beg.
Yes, that is what I said.
Yeah, Abu Emmanuel,
Thank
end the
you.
meeting. You are the host.
Thank you.
Is Abu with us?
I think it's Abu.
Abu Emmanuel, are you with us? Meanwhile, Silas.
Yes, this is Silas.
And Silas, please go to, are you on the students WhatsApp group?
Yes, yes.
Okay. And you can chat me there.
Okay,
you will see
okay,
my
I
number
will.
easily. Yes, sir.
Okay. Okay, I will do that.
Abu Emmanuel, please. The guy even leave this thing. The mic is even on. And then he's nowhere to be found.
It might be network.
Oh my goodness. Now I have to go and start calling this man to end meeting. They even send me for class rep again, sir.
Fine, I'm calling my name to chat you up now.
Man, precious.
Yes, sir.
Now you get my phone now. So please, we need to talk personally, man. Abego. Because this one, everything is bitter in this class. Bitter 1, bitter 2. My God. Oh, who is this person? Abu Emmanuel. Do I have his number? Hey, number. Is that our new class? Our new lecturer? Abu Emmanuel.
Hello, sir.
Yes.
I'm trying to. My network has been troubleshooting. I'm trying to actually go off.
Who is talking?
It's Abu.
Okay, Abu, what you will do is just try to leave the meeting. So they will tell you whether you should leave alone or you want to end the meeting. So just end the meeting.
Okay.
Yes.
Mommy, sleep that. Mom. Mommy.
They're not showing me the option, no. How comes I won't turn host today?
Because of Messi. Okay, so can you see where that the red sign they are showing leave? Can you see?
Red sign?
On top of your screen, yes. You will see. Are you using your phone or your system?
I'm using my phone.
Okay, so by your right, you will see leave. There's a red sign up over there with leave.
What I'm actually seeing is actually back to meeting schedule. I don't. Oh, what if I just off my
Okay.
data now? Whoa.
No. Okay, look at what we have, Umba. Go to participant. Let me show you something.
Okay.
Are you on participant?
Yes.
Can you
Okay.
see my name? Can you see Fine Theokosu?
Yes, I'll see participant.
Can you see my
Ah,
name?
yes.
Okay, tap on my name.
Okay.
Can you see make host? Can you see something like that?
Yes.
Well, make me the host, then I will end the meeting.
All right, sir. Thank you.
Okay. All right. So good night.
Good night, sir. Good night, sir.
Teacher Fine, well done.
Thank you, ma.